Okay, good morning. So if you remember last time we talked about the chain rule, which is actually probably the most important part for differentiation. You need to master this skill. Very good. I didn't express the theorem formally for you last time, but if you want to write it really formally, this is the content of the theorem. It tells you that if you have two functions, let us call them f and g, if you know that function g is differentiable at a, but the second function f is differentiable at the outcome of acting g on a, okay, then FOG, do you remember, it's called the composition of these two functions, is differentiable at a, and this is the formula that you get. The derivative of this new function FOG at the derivative of this FOG at point A is the derivative of f calculated at the point GA multiplied by the derivative of g calculated at point A. So this theorem tells you that if g is differentiable at a, it means that g prime of a is a number, and f is differentiable at g of a, it means that this is also a number. Then if you multiply these two numbers, you will get the derivative of the composition of two functions at point A. Okay? So you don't need to be worried about the formal way of expressing this. Usually, instead of FOG, if you remember, let me just remind you a little bit. What was FOG? If I give you, for example, a function f of x equals to sine of x, and if I give you a function g of x equals to, for example, x squared plus 2x, then if I ask you what is the meaning of FOG, the composition of f and g at point x, this means, this is just a symbol which means you act g first on x. When you get the output, you act f on the output. This is the meaning of this symbol. So actually this is what even you have studied this form in Math 1C, so that is not very surprising. The only thing that you need to learn is that there is a specific symbol for that, and this operation is called composition. Yeah, so you have to use the word composition, not combining or something. So we are composing f and g. G acts first, f acts after that. So sometimes people call it f after g, showing that f applies after g. So if I ask you what is this function, then you would say that g acts on x first, gives you x squared plus 2x. So this g of x becomes x squared plus 2x. And then f is supposed to act on the outcome, but the outcome is this. F is acting on this new outcome. Yes? But what is the role of f? Whatever you give to f as x, f will take the sign of that input and gives it back to you. Now you are sending x squared plus 2x into this function. F will do the same thing. It will take the sign of this number and gives it back to you, yes? So that is what we learned. So if you want to have the diagram, if I ask you what is f doing for you, you can consider it as an operator. You send in x. X is a representative of the input. Whatever it is, it doesn't matter. So you send x in, and then you get sine x out. Okay, so if I send x in, the output is sine x. If I, for example, send y in, the output is sine y. Whatever I send in, the function will take the sign of that and gives it back to you. Yes? And now I have another function, which I call it g. Whatever I send in, like x, the function will square that input, multiplies the input by 2, and add the results and gives this back to you. Now you want to apply these functions one after the other. That is the meaning of composition. Yes? So it depends which one you want to do first. if you want to do in this way, this is the outcome that I get. So it means that if you want to imagine FOG, if I give you these machines to you, then FOG is a new operator, so that when I send X in, what is the result coming out? Can you tell me now? If I give you these two operators and I ask you to write something for this, what do you write? It's on the board actually. It is sine x squared plus 2x, yes? Sine x squared plus 2x. Okay, let me also ask you to specify this for me. Here, F is acting, so F is after G, here G is after F. Do you think the results will be the same? If not, what would be the answer to this one? So here, F is acting first. So I put X into machine F. It gives me sine of X as the output. Now G is going to apply on the output coming out from F. Yes?
So sine squared x plus 2 sine x.
Exactly. So it becomes sine squared x plus 2 sine x. Yes, is that understandable? Yes or no? So here, F acts on X, it gives you sine X. Now you are, instead of X, you are sending sine X in. So it means that it will do the same thing. So it will square your input, but your input is sine X. So it squares it. It multiplies your input by 2 and add them together. So you see that the results are quite different. Yes? So be careful in which order you are composing these functions. Okay, and if I ask you what is the main content of the chain rule, and by the way, there is other names for these functions. So you see, for very natural reason, this function is called the inner function because it is inside. And this function is called the other function, yes? Okay, so if I ask you what is the point of the chain rule, you would say that this is a theorem that enables us to calculate the derivative of the composition of two functions if I know the derivative of these two functions separately. Yes. For example, in the I think next time we will learn how to differentiate sine x. You didn't have this in Math 3C. So, okay, we will learn what is the derivative of sine x. We of course already know what is the derivative of x squared plus 2x. So the chain rule is a rule that enables you to calculate the derivative of the composition of these two functions if you know the derivative of each one of them individually. So that is the content of the chain rule, yes? And that is extremely important because there is no other way to get this function out from these two functions except composition operation. If I add these two functions, it becomes x squared plus 2x plus sine x, which is not this function. I don't know if I multiply them, divide them, subtract them, raise them to some powers. All these kinds of operations will not give rise to the function that I want to. Yes? So this means that the chain rule is actually has a unique position. Many functions can be written in terms of composition of simpler functions. And if I know how to differentiate the simpler functions, the chain rule will enable me to calculate the derivative of a more complicated function. Is that understandable? Yes? So that's the content. Okay, so usually, for example, let me give you an example. I want to solve it again from scratch, but for example, assume that you want to calculate the derivative of this function. So let me change the letter from f to h here. So if I give you differentiate this function, so you see, there is no way that you could do it in Math 3C, this function, okay? We want to do it using this rule. Okay, for this one, let me write it in a little bit more practical way. First of all, instead of letter A, because A is a number, but in principle I am interested in differentiating the function at a typical point, so let me change A to x. Okay, so then on the right hand side I will have f prime of g of x multiplied by g prime of x. And instead of writing f of g, okay, so I would say f of g prime of x. But what is the meaning of f of g? We just learned f of g means f of g of x. So this becomes f of g of x totally prime. Okay, so I would recommend you to learn the chain rule connecting these two. Okay, so let me write it here for you. So if I have f acting on g, it becomes a new function, and if I want to take the derivative to differentiate the total new function, what should I do? I will take the derivative of the inner function and multiply it by, I take the derivative of the other function, but I calculate it at g of x, and then multiply these two. So this is actually more practical for you in this course to learn it in this way. Okay, so here it's a function. I want you to decompose this function to two functions so that when I compose them, it gives me h back. It's very simple to think about which function is the inner function here and which function is the other function. So if I give you x, if you want to understand it easily, you say that, okay, if I give you x equals to 5, for example, how do you calculate this? You calculate this one first by putting 5 in it, and if after you got the answer, you take the third root of it. So the one that you are doing first is the inner function. The one that you are coming next is actually the other function. So if I ask you, can you tell me what is the inner function in this problem? So what is that? And what is the other function that I want to call it f of x? Okay, what is g of x? X squared plus 2x minus 1, yes? And what is the other function here? Third root of x, yes? Is that understandable? So if I compose these two functions, f after g, the answer becomes exactly h of x, yes? So then hopefully everyone agrees that h of x that I have here is nothing except f of g of x. Everyone agrees that what I have written here is f after g. Yes? Okay, and then because h is f after g, and I want to differentiate h, so this means that h prime of x is equal to f after g of x prime. And this is exactly the formula in the chain rule. So I know what to do. I need to calculate g prime of x, which is extremely simple. So what is g prime of x? Is 2x plus 2. So then I need the derivative of f, but it needs a little bit more work. The derivative of f is, okay, how should I calculate the derivative of f? Yes? I have to write it as the third root. Yeah, so x to the power of 3, yes? 1 over 3. So first you need to write it in this form for yourself. And then you can use the formulas in Math 3C, which of course we also reviewed. F prime of x is what? 1/3 goes down, x to the power of minus 2/3. Let me simplify this a little bit. So what happens? It becomes 1 over 3. It's important to learn to simplify. Now you are grown-ups, yes? So simplify this. What happens? Because usually the derivative is finished here. But you need to be able to simplify. So I would write it as the third root of x squared. So I will prefer to stop there instead of writing it in this form. But this is not finished. You need to learn this is not f prime of x. This is f prime of g of x. So what does it mean? It means that f prime of g of x. What does this mean? This means that go to the derivative function, which is this one, and instead of sending x in, now send g of x in. So what will happen? It becomes 1 over 3, the third root of g of x to the power of 2. Is this part understandable? So instead of f prime of x, I have to calculate f prime of x first. And after that, I have to calculate f prime of g of x. What does it mean? It means that instead of sending x to f prime, I am sending g of x to f prime. So it means that wherever I see x, I replace it with g of x. But of course now, if I ask you what is g of x, you would say that g of x is that expression. So I will continue. It becomes 3, the third root of that expression to power 2. Yes? And then finally the question mark is equal to this one that you get at the end multiplied by this one that you get at this end. And that's it. And if I multiply this by that, I would prefer to write it in the numerator because 1 times that is just this one divided by 3 third root of x squared plus 2x minus 1 squared. Yes? So that is the derivative. And we are very lucky to have this because otherwise you can just check if you really want to calculate the derivative of this using the definition of limit process. I don't know if we can succeed to do. Of course it is possible to do that, but it is really, really lengthy. Okay, so if you want, you can at least write it down to see what will happen if you really want to continue and calculate that length. So that is the derivative of that function that you see there. Is that clear? But of course, I will teach you. This is the way that I want you to learn the content. I will teach you. Of course, I will never do it in that way. I can do it faster. And I will teach you how to do it faster. It doesn't mean that this is not this method, but you don't need to write so much to answer this one. You need to think in this way, but you can write it a little bit more compactly, and I will tell you how. But before that, let me ask you some questions. Okay. So if you think, if I ask you this function, so for example, if I ask you, of course we haven't studied these derivatives yet, but let me just assume that I am asking you to differentiate this function. For example, if I give you this function, h of x equals to sine of the square root of x squared plus 1. We don't know how to do it right now. My goal is not to differentiate it right now, but my goal is different here. So how many functions here are involved to be composed? I'm not forcing you to do it in composed way, but I hope that you agree with me there is no other way to make this function by adding functions or multiplying functions. We have to compose them. But how many functions are involved? 3 functions. So what is the most inner function? X squared plus 1. How do you understand that? Assume that you put x equals to any number and you want to calculate this combination. What do you do first? You calculate this one first. After it is finished, you take the square root. After that is finished, you take sine. That is the order that you do it. So there are 3 functions involved, yes? So if I want to write them as a composition, the most inner function, which acts first, let me write f sub 1 for it, then it becomes x squared plus 1. What comes after that, which I call it f sub 2, f number 2, is a squaring function. What comes after that is what? A sine function, yes? So first of all, do you understand that if I compose them, f3 after f2 after f1, I will get this? Yes? Is that understandable? Okay. But now the chain rule apparently works for two functions. So we immediately want to modify this to extend this from two functions to three functions, from three functions to four functions. Yes? So in principle, if I ask you what is h of x is f1 of x, after that f2, after that f3. This is the situation that I have right now. But I want to take the derivative of this function. So my question mark is the derivative of this function. So it means that I have to differentiate this function. But the main chain rule, if I want to write it here, is only for two functions. I want you to learn how to extend it to more than two functions. So what was the formula? F prime of g of x times g prime of x. Yes? That is for two functions we already know. But do you think I can use that formula to extend that formula for 2 to 3 or more functions? So how should I do that? Anyone else? Yes?
So you can take the first two functions inside of f3, calculate that first, and then...
Yes, exactly. So you can take these two functions and call them a new function. Yes, so okay. So let me come up to here. This is the composition of two functions, but it becomes a new function at the end. So let me call it g of x. Yes, and I want to differentiate it. Then I have two functions involved. The other function is f sub 3, the inner function is g of x. And that is exactly the rule that I have. So let me write it down and then see what happens. So what will happen here? This tells me to differentiate g of x here. But g of x is this one. So it becomes f2 after f1 x differentiated multiplied by the other function derivative acting at the inner function. So the other function here is f3. I take the derivative and act it on and apply it on the inner function, which is g of x. But g of x is this one, so let me just repeat it. Yes? But of course, again, this is another chain rule, and that is exactly why we call it the chain rule. Whenever you think that this process is finished, another loop of the chain comes in, so you have to do it over and over again until the very end. Yes? So this one is done. Yes? But what can I write for this one? Another chain rule here. Yes? There is f2 after f1. So what I have to do, I have to differentiate the inner function and multiply it by the derivative of the other function applied at the inner function. So that is the formula for the chain rule for three functions. Okay, so let me just make sure that you really understand that. So this means that in the future, if we want to differentiate this function, I need to know the derivative of f1, which you already know. You need to know the derivative of f2, which you already know. And you also need to know the derivative of f3, which is still you don't know, and that would be the topic of the next lesson. Okay? But in principle, if you know the derivative of these three functions, immediately you can use this a little bit long rule to calculate the derivative of that function. Yes? Okay, so make sure that you understand everything. Let me just extend it to 4. If you can just write it down and then it is clear. So I don't want you to do it step by step. I want you to write the final 4. Okay? So I have f4 acting after f3, acting after f2, acting after f1. Yes? And then you want to differentiate. Okay, so what do you do? So we can also start with the other function. So if I want to write the final form, the last form of this one, what is the answer? It becomes the othermost function derivative, yes? But be careful, calculate it where? At the inner function, which is this guy. So it becomes f3, f2, f1, x. Yes? And then multiply it by what? Can you tell me? F prime 3, yes. F3 prime, yes. F3 prime, but calculated where? at the inner function, f2 of f2 of f1 of x. But then calculate, but what should I do? Multiplied by the derivative of f2 calculated at the inner function. And finally, this one. So that would be the formula. Yes? So if your function is a composition of a lot of functions, then differentiation process is actually a very long process. And then you have to master this. I will give you exercises. I cannot give you very nice exercises right now because whatever I want to write involves other functions yet. We haven't studied that here, but we will be able to do that later. Any questions here? Okay, now let me tell you how to do it a little bit faster. Okay, that's exactly the same formula. So what I'm telling you is that in your head, you can call g of x to be a variable, call it u. And then here, g of x becomes u of, so let me call it yes. And then this becomes what? This becomes u prime, yes? The whole package. So what you can write a little bit shorter version of the chain rule. You can say that f of u prime is equal to f prime of u multiplied by u prime. That is a better version to have in mind if you want to do it for practical purposes, to do these things quickly. So, but let me write. If someone asks what u is, you would say that u is g of x. But before cleaning what I have written here, look. That is a very delicate point here I want you to understand. What is the difference between this symbol that you see? You see fg prime, but here you see f prime g. What is the main difference between these two? Apparently they are not equal. Yes? Because this one is not equal to this one. Is equal to this one multiplied by something. So in principle, this symbol that you see here and this symbol that you see here are quite different. Even though both of them have f prime, have f and g and prime involved. So what is the meaning of that? I want to really write this down for you somewhere, because I haven't seen them in the books, write them explicitly. I want to you understand what is the difference. So can you tell me what is the difference between this symbol? Yes? What is the difference between this symbol and this symbol? Of course, you see the difference now. They are not equal. Hopefully you agree with me that there is a difference between these two. Otherwise, I should put equality between them. But equality between them happens if I have that extra factor. Okay? But even if you don't know the chain rule, forget about the chain rule, you need to understand this one and that one are different. Extremely important to understand what is the difference between them. So now can you explain it in words? What is the meaning of this symbol? What is the meaning of this symbol? Yes?
You want an equality?
No, of course they are not equal in general. You can see that.
Yes.
But assume that you don't know anything about the rules. Assume that you haven't heard about the chain rule. But you know the derivative. Okay? For example, you are a Math 3C student I give you f of x. By the way, you could do it in matrix. For example, I give you f of x to be, I don't know, x to the power of 2. And I give you g of x to be x to the power of 2x plus 2x. So let me make it 3, not get confused. So I could actually ask a Math 3 student, Math 3C student, to calculate this in the exam. And calculate this in the exam. But the Math 3C student doesn't know about the relations between them in general. But it doesn't mean that they cannot calculate that. So let us go back. You just assume that now you are a Math 3 student and then you have finished the derivative. And in the exam, I give you two functions and I ask you to calculate this and I ask you to calculate this. And you don't know anything about the chain rule. Still, you can solve the problem. And if you can solve the problem, then you will appreciate the difference between these two. Now I want to hear from you. You are a Math 3C student now, okay? We go backward in time, and then I'm asking you, which one do you want to answer? So let me first discuss about this simple. Okay, anyone? From perspective of a Math 3C student. Yes, Dylan?
X squared plus 2x, you put it in the left function, and then you take the derivative.
Yes. Yes. That's exactly the way that you have to do it. So what you do, this symbol tells you that. First substitute and then differentiate. Be careful. This symbol, by the way, let me make it 2 so that it is easier for us to calculate. So you said that I put g of x into f of x to generate this, yes? So let me see. Am I starting the differentiation process now? No, I am doing the replacement process. So I will do f of g of x first as a Math 3C student. So what will be the answer in your head immediately? What is that? Just tell me. Read it for me. X squared plus 2x to the power of 2. Yes? And then you get a new function and you differentiate it. But in Math 3C student, a Math 3C student doesn't know how to do that. They have to expand it. So let me expand that. So this becomes x4, 2 times the first one times the second one, and then the second one is squared, which is this one. And then they will write this answer for me. What is the answer? It's 4x cubed plus 12x squared plus what? 8x. So in principle, they don't know anything about the chain rule, but they can still solve the problem exactly like this. So but remember, the person who solved the problem did the substitution process first and then started differentiation process. So here, substitution comes first and then differentiation comes after that. But now assume that the same student wants to calculate this one. What we have to do here? Yes, Dino?
First take the derivative of x.
You first differentiate and then substitute. Yeah, so that is different. So if you want to calculate this, you have to start calculating f prime of x. Yes? So be careful. Here, substitution process started first, differentiation process followed. But here, differentiation process starts first, so it becomes what? 2x. And then f prime of g of x, this is the place that I have to do the replacement. So what is the answer? Is 2 times g of x, yes? But what is g of x? Is 2 times x squared plus 2x. And then if I simplify that, you see, they are not the same. So be careful. This one you replace and then differentiate. Here you differentiate and then replace. And as you see, the results are quite different. So the chain rule is a rule connecting these two processes together. The chain rule tells you what is the relation between this and the previous one. What is the relation between this and that one? And of course, so you see what I'm telling you, you were able to calculate this without knowing the chain rule at all. So why we are learning the chain rule? Can you answer this one as well? So if we could solve the problem, why should I know the chain rule in the first place? Yes?
For functions that we don't understand.
Exactly. There are functions that we don't know what will happen if I do the substitution. When I do the substitution, it is not a simple function, it is still a composed function, so I need to know what to do. Yes, otherwise we really don't need the chain rule. Yes? So what happens is this. The chain rule tells you what is the connection between this and that. And what is the connection? If you want to do it, this one, you can do it in that way, or the chain rule. So what is the chain rule? The chain rule tells you that you have to multiply by an extra factor of g prime of x. But what is g prime of x? Is 2x plus 2. And if I multiply 2x plus 2, by this answer, I will get exactly this answer. So you can check that. 2x times 2x squared becomes 4x cubed. 2x times this one is 8x. And this one times that one, no. What is the... so let me see. Oh, okay, sorry. So if I multiply this by that, it becomes 4x cubed. Yes, if I multiply this by that, it becomes 8x squared. And then if I multiply this by that, it becomes 4x squared. And then if I multiply this by that, it becomes 8x. And these two becomes 12x squared. Yes? So, this is extremely important to learn what is the difference. So let me write. This is so important, I think that it is better to write it as a remark, okay? I hope that everybody understands what is going on. So do you appreciate now the difference, yes? So, if g of x prime, so first substitute and then differentiate. Okay, but if, sorry, I have to put it prime here. So, but this one means first differentiate and then substitute. Yes? Are these two operations commutative? No. These two operations are not commutative because you see the results might be different. Okay? So, the chain rule is a rule that connects these two operations. The chain rule tells you that the first one is not equal to the second one, but it is somehow related by multiplying by an extra factor of g prime. Yes? That is the chain rule. Now my question is that, can you imagine a scenario that these two are the same at the end? It is also sometimes possible, but that is not a general rule. In general, these two are not the same, as you see as a very simple example on the board. But now I'm asking you, is it possible in some cases that these two become the same? Anyone else? Yes?
Maybe if g of x is equal to 1.
No, g prime of x is equal to 1. Yes? So it means that if g of x is a function whose derivative is equal to 1, then they become the same. But when the derivative of g becomes equal to 1, x or x plus a constant, the most general case. So that is exactly the same scenario. So if g of x is actually equals to x, let me just write it x for the time being, as Amanda mentioned. So if g of x is equal to x, then these two are the same. And there is no surprise, by the way, for that. Why? Because if g of x is x, then this means f of x totally prime. Yes? Instead of gx, I put x. This means f prime of x. Of course, this is clear that if this is x, there is no difference between this symbol and that symbol, yes? Or, of course, not only this one, but any constant, yes? Any constant is also working because the derivative of this is still 1. So if I ask you what is f prime of x plus a constant, you would say this is exactly the same as f of x plus the constant totally prime. So in only this case, they are the same. Otherwise, they are not the same. So that is extremely important to understand what you are doing in the chain rule. Okay, is that understandable now? Okay, now let me do one exercise using this U trick. Of course, that's exactly the same, but you really don't need to write so much. Okay? And I want you to learn this one. I want you to, after understanding the concept, I want you to be able to do it fast. Because otherwise, it will be very boring for you. Okay. So, for example, I give you h of x equals to, let me just solve a simple problem here, to the power of 100. So I want to differentiate this function. Of course, you can start, you see that the inner function is this one, the outer function is x to the 100. Okay, so you can combine them. This method is good, but you can do it in your head. You should take something to be u in your head. Okay, I will take the inner function to be u. You even don't need to write it down. You can imagine that. Okay, and then you are facing u to power 100. Okay, differentiate it as usual. So assume that u is x. So how do you differentiate? If I give you x to power 100, you know what to do. What you're supposed to do, you just put 100 down, x to the power of 99. Do the same thing, becomes what? 100, u to power 99. But what is u? x2 plus 2x plus 5 to the power of 99. In the previous case, you have to stop here, but here you have to continue one more step by multiplying it by u prime. Yes? So what is u prime now? 2x plus 2. So this is the way that I want you to do it. That's exactly the chain rule, but I have done it in a way that is much faster. Is that understandable? So you have to think in this way. For example, if I ask you h of x is equal to, I don't know, the third root of x to the power of 2 minus 5x to the power of 2. And I want you to differentiate this. Okay? So, what should I do here? So first of all, you have some experience. The third signs are not very useful when we want to differentiate. We always write them as a fraction power, yes? So the first thing that you can do, let me write it with blue. So the first thing is not be in hurry to start differentiation, to do the same thing that you have learned so far. So I would write it in this form. So this one is exactly the same as this one, yes? I'm using this formula. I hope that you remember these things, yes? The mth root, a to the n, is a to the n over n. It's extremely important for this course to remember these things. Okay, so I give you this function to differentiate. You have a little bit of experience with working with these third roots and things like that, so you know that it is better to write it as a fraction power. But then I want you to do the chain rule using this faster way. So which one it is good to take to be u in your head? What is that one? What should I call u here?
X squared.
X squared. You don't even need to write it down. Here, for pedagogical reasons, I'm just writing them down, but you really don't need to do that. And you start differentiating just right away. So h prime of x becomes equal to what? You can imagine that u is x. What do? You bring 2 over 3 down. You write u to the power of 1 unit less. What is 1 unit less? 2 over 3 minus 1 is minus a third. But instead of u, you just write this one. If it was x, the process was finished here, but now you have u, because of the chain rule, you have a u prime at the end. So it means that, by the way, it means that you have to, let me write it down. Of course, I really want you to do it in your head. But sometimes this becomes so complicated that we cannot do everything in our head. We have to write it down gradually and do the process. So this part is the new lesson, the chain rule, yes? And of course, you have to continue until that you don't have this prime left. Of course, you could do it in your head, but let me write it in two parts. So it becomes this, x squared minus 5x to the power of minus a third, and multiply it by 2x minus 5. Of course, this is finished, but I want you to be able to write it more beautiful, yes? So how? So you write 2 multiplied by that, and then what you do, you take it to the denominator, and instead of positive 1/3, you write the third root. It's easier for us to understand the third roots than this one. So I will stop here, but of course, the lesson, the new lesson is finished here. Any questions? Okay. I want to write one function and wait for you a little bit. If you can do that, it means that you really understood what is going on, okay? So let me write this function for you. H of x is equal to square root of x minus square root of x squared plus 1. So I want to give you a little bit of time to think about this problem, yes? My question is, find the derivative of h of x. Of course, assuming that this function is defined. We always, when we differentiate functions, we are differentiating on the domain. Yes? So if you want, I can write it plus. You don't be worried about that negative sign. Yes. Okay, any opinions? Any answers? Okay, let us see why if you couldn't find the answer, why. So if you want to solve this problem using this U trick, I hope that you agree with me. This is not the sum or sum rule. This is the composition rule. Yes, that's the chain rule. Yes? And what is the inner function? If I ask you what is the inner function, by the way, what do you say?
X squared plus 1?
No. X squared plus 1 is not the inner function in this case. Because if you say that is the inner function, and then what is your outer function? There is something going wrong here, yes? It's not, yes?
The most inner function is x plus x squared plus 9. Yes, x plus x squared plus 1.
X, yes. The whole expression is u. Because if you say this one is u, then okay, for the time being, let us assume that x squared plus 1 is your inner function. Okay, but you have to tell me what is the outer function then. What is the outer function? What is the outer function? It is not clear, yes? It's not inner and honor here. It's a combination of composition function and other rules. Yes? So here, as actually Jakub mentioned, here you have to consider this for the time being as your u. Yes? Okay? And do you remember I told you that in this course I really want you to memorize this. Otherwise I have to do it over and over again from scratch, and I'm lazy to do that. Do you remember? I want you to memorize it right now. Yes? If you have a square root of x prime, we got it. It's 1 over 2 square root of x. Yes? Okay. So now instead of the square root of x, I have a square root of u. I just told you what to do. The rule is the same. But you have to remember, the process will not finish until you multiply it by an extra u prime. That is the difference. Think it in that way. So if I ask you what is h prime of x, you will follow exactly the same rule. 1 over 2 square root of u, but u is this expression. Don't write it so many things. You just immediately apply it. But the process is not finished. The process is not finished. For x, the process finishes exactly there. But for this, the process is not finished. You have to multiply by what? You have to multiply, let me write it, don't be in a hurry. You have to multiply it by u prime. So I want to wait a little bit so that everyone agrees that you understand that. Is that understandable? So I took that one u. I know what is the formula for a square root of x. The only thing here, I have a square root of u. The rule that applies is the same for the first stage, but you have to multiply by u prime. And then the process will finish when there is no track of this prime left in your problem. So it means that the problem is correct up to here, but not finalized. So then you have to do a lot of copy pastes, yes? So this one doesn't have any prime, so you have to you shouldn't be lazy. You have to copy paste in full details. And then you have to think about a new problem. Throw everything away and concentrate only on this bit. Is this the chain rule right now? Yeah?
Not right now.
Yeah, it is the sum rule. Because I have the sum of two functions. So I have to apply the sum rule here. Let me write them in detail, even though you can do it in your head. So I take the derivative of the first one plus the derivative of the second one. So this is the sum rule, not the chain rule. And then the derivative of x is just 1, so you have to do a copy-paste again. Of course, by practice you will be much quicker, you really don't need to write that much. But this is, even though if I want to do it, I do a lot of things in my head, but I will go through each step in my head. So be careful, I review what rules that I am using. This is extremely important, otherwise it will be a random process for you. So the derivative of this one, we know this is 1, but the derivative of this one, what the rule is here? This one is again the chain rule. So then you have to give the rule of u to this one, because you don't care about the problem so far, you are only caring about this bit. So then this is your u. Okay, can you tell me what should I do? I would write 1 over 2 square root of u, but the process is not finished. I have to multiply by the derivative of u. So you see that in the process of differentiation, a lot of differentiation comes in. Okay? And then the derivative of this one is the last bit that I have to do, and then we know what is the answer. So what is this one? So I have to copy paste again. This seems a little bit awkward in the beginning, but you immediately learn that, I'm sure. So this answer is what? 2x. So this becomes this one. X squared plus 1, and then you have times 2x. This is your derivative without simplification. If you want to, for example, you can write x here on top, simplify this with these 2's, and then you have your answer. So that is also something that I want. So any questions here? Is that understandable? So sometimes you have a mixture of rules. The previous rules, for example, the sum rule, and sometimes we have to apply one or more chain rules. Okay, so let me give you another example. Let me give you another example. So h of x is equal to, for example, 5 divided by x plus square root of let me make it 2x cubed plus x squared minus 2x to the power of 5, to the power of 6, for example. If you don't mind, I think this number becomes very big, so let me just write it 1. It doesn't matter here. Okay, so let me pause the video and give you time to do this. We want to differentiate this function. Okay, so what should I do here first? Yeah, that's the best thing, because it's not that hard to realize that. How do you realize that? Assume that you have to simplify the problem for yourself. If I ask you to do this in matrix C, what is the first thing you do? You bring this up and make it negative. Okay? But instead of x, you have a little bit more complicated function, but that's no big deal. You have to do the same method, yes? So what you do, if I want to do it, I would do it in this way myself first. Okay. Do you want to continue then?
Okay.
Yes?
So you bring the minus 6 down.
Okay, so you want to use the chain rule or what? Okay, the chain rule, so you need to tell me what u is.
U is 2x.
The whole combination is in your head u. And then I have u to power negative 6. Assume that it is x to power negative 6. You can do it, yes? So the derivative h prime of x becomes minus 6 goes down. And then you have u to power 1 unit less, which is minus 7. But instead of u, just write this one. Minus 7. But in the previous case, the process was finished here, but this is not finished now. I have to multiply by u prime. So u prime is the important lesson today. You have to multiply by u prime. And I recommend you, of course, I really want you to do it in your head, but not for the first few examples, unless you are feeling very comfortable doing that. Okay, now which rule applies? Yeah, the sum rule or the addition rule, yes? So the addition rule applies here, but you have to do the copy-paste a lot. So minus 6, 2x to the 3 plus square root of x squared minus 2x to the power of minus 7. And then let's do this part in our head. So what is the answer? Because I have to differentiate this one plus differentiate this one. This is not the chain rule, this is the sum rule. So it becomes what? 6x to the power 2. And then I have to differentiate this function. Yes? But in the second part, I have to use the chain rule once more. But what is playing the role of u in this new problem? This one is playing the role of u. The square of u is the formula on the board. You have it for x. For u is more or less the starting part is the same. So it becomes 1 over 2 square root. Instead of x, you have u. But the process is not finished. You have to multiply by u prime. Yes? And still there is a prime left, so you have to rewrite this. And usually for the chain rule, I am not sensitive to simplification that much, because I want you to learn this process. So I give you probably big functions. So simplification is not important for us here. So this becomes 1 over 2 square root of x squared minus 2x. And then I have 2x minus 2, the derivative of this one. And because there are no primes left, then I am done. So that would be my derivative. And I hope that you agree with me. If you want to do it using the definition of the derivative, yeah, you can imagine how hard it would be. So, okay? So this is what I want you to know. And then, so here, let me write something here for you. So far, we don't have that much formula. We started adding formulas in our table later. Trigonometric functions, exponential functions, logarithmic functions will come in. And then inverse functions will be left for you for the university. So here, only you get the formula of the chain rule in the formula sheet, and you get these table only. So your table will be f and f prime. Only for x you will get it. You will not get the chain rule version of that. You will get this formula, unfortunately, in the formula sheet, because I don't understand if someone doesn't know about the chain rule, what they know about derivative, I don't know. But anyway, f and f prime, so you have a constant, the derivative is 0. You have x to power c. The derivative is cx to the power of c minus 1. This table, as we progress, we will continue to add more items to it. This will be given to you. But you yourself, you have to interpret it in this way. So the constant again is 0, but u to the power of c is very similar to this rule, but you have to multiply by an extra u prime. Yes? So if I want to set up a new table, which you will not be given, okay, this means that I replace x with u, but I have to remember, I have to multiply by a u prime at the end. Yes? So here I would write that u is itself a function of x. Yes? So for example, if you have a square root of x here, we know that the answer is this, but the chain rule version would be but multiplied by extra u prime. So you see, this table will not be given to you in the formula sheet. You only know this, and you know the chain rule, so you yourself have to combine them to construct new formulas for yourself. Okay, so later we will progress here. We will add more functions to this column on the left and answer the derivative on the column on the right. Okay. So what we can do right now, let me ask you another type of question. Example. Let me write this. Let f and g be differentiable functions. So don't worry about that part. Differentiable functions. It means that the derivatives always exist. Functions. And let me just write f be a differentiable function. And let h of x be equals to f of x squared plus 2x. Let me write fx plus 3. If f prime of 3 is negative 5, determine h prime of 0. This is also a different type of question that you might face for the chain rule. So here, I haven't given you the explicit form of your function f. You don't know anything about f. Only you know that the derivative of whatever this function is, calculated at 3, turns out to be minus 5. That is the only piece of information that you know about function f. And then I am telling you I have a function h of x, which is f of a new combination, x squared plus 2x plus 3. I have given you only this piece of information, and I want you to calculate h prime not of x, because you don't know how to do that. I want you to calculate h prime of 0. Okay? So this type of question, that's also I want you to learn. So here, if I write h of x is equal to f of x squared plus 2x plus 3. First of all, do you understand the connection between this problem and the chain rule? Do you think that this should be somehow related to the chain rule? Yes? Why is that? Because h of x, if f acting on a new function, yes? It's a function, it's not f of x. It is f acting on a function of x. So this plays the role of the inner function. After that, f comes in. F after that function, yes? And then you want to calculate the derivative of h at 0. Okay, you know what to do even in Math 3C. If I give you a function, if I ask you to calculate the derivative at a given number, what you are supposed to do, you first differentiate. Whenever you find, you replace x with the number. So the same thing applies here, exactly as before. So I have to write h prime of x. So if you want to, let us do it in this way. I would write hx totally prime is equal to f of x squared plus 2x plus 3 totally prime, yes? Because you are telling me that these two functions are equal, so if I calculate the derivative of the left one, it becomes equal to the derivative of the right one, yes? But now, do you remember, can I write this as h prime of x or no? Because do you remember I told you that this is an exception. H of x prime, there is no difference between this symbol and h prime of x. Yes? But this one, there is a difference. Because here I have to use the chain rule. Yes? So what is the answer? It becomes, do you remember? The outer function prime calculated at the inner function. Yes? Times the inner function derivative. Yes, is that understandable? Okay, but now we haven't finalized the differentiation process yet because still I have a prime left there at the end. Of course, I also have a prime here, but I cannot do anything with that because I don't know f. F is not given, only I have one single piece of information about f. But then the derivative of this one, so I want to repeat it this here, h prime of x is equal to f prime of x squared plus 2x plus 3 multiplied by 2x plus 2.
Yes.
Okay, that's the end of this. I cannot go further because I don't know f. But in this problem, I really don't need f because my goal is to calculate h prime of 0. So it means that I have to replace x with 0. So this becomes f prime. If I replace x with 0, what do I get? 3. And if I replace it here, what do I get? 2. But this is exactly what is given in the problem. So the person who designed the question actually, in this case me, yes, was thinking about this problem. Yes? So here, if I gave you f prime of 2 is minus 5, this would be the dead end. You cannot continue because you don't know anything. But here, it becomes minus 5 times 2. The answer is minus 10. So that is also sometimes questions of this type that you need to know how to solve. But that is easier, I would say, than differentiation. Any questions here? Yeah. I wanted to say something about the proof of this rule. I don't know, we have a little bit of time. Okay, I can take it for the next time. So the next time I will start with the proof of the chain rule. And then immediately I go to the derivative of sine and cosine functions, which is the next section. And of course, whenever we learn a new derivative of a new function, then you can do a lot of new things with the chain rule. Yes? So you can combine two or three or more functions together. And then I want you to really learn how to differentiate using the chain rule very properly. Okay, no questions? Thank you.